Hey everyone, welcome back, and today let's solve Leetcode problem 921 titled Minimum Add to Make Parentheses Valid. So a parentheses string is valid if and only if it is the empty string, or it can be written as AB, where A is concatenated with B, where A and B are valid strings, or it can be written as A solely, where A is a valid string. So we're given a parentheses string S, and in one move, we can insert a parentheses at any position of the string. For example, if S is equal to the following, we can insert an opening parentheses to be this, or a closing parentheses to be the following, right? And which are both considered to be valid. So we have to return the minimum number of moves required to make S valid. So in example 1, we have S to be an input string of 2, or rather an opening parenthesis closed by a closing parenthesis and one extra closing parenthesis. In this case, this portion of our input string S would be considered valid, but we do have one extra parenthesis that's not being closed, or that doesn't form a valid group, and so we'd have to actually use one swap or one move to add one more opening parenthesis at the indices before this to actually form a group or a valid parenthesis with these two variables. And so for that reason, we would take one move to make this input string S valid. And in example 3, we have 3 opening parentheses, but we don't have any closing parentheses to form any valid groups or groups of parentheses, and so we'd output 3 because we'd need 3 closing parentheses after these 3 opening parentheses to validly close them all, right? So if you guys have noticed, basically the number of parentheses that don't form or don't make up a valid grouping is basically the number of moves that we need to add extra parentheses to make up for that imbalance, right? And that's basically how our code is going to be structured as well. So what we're going to do is first we're going to have an empty stack. And this stack is essentially going to keep track of all of the different elements or all of the different parentheses that don't form a valid grouping of parentheses. And that's basically going to signify how many moves we need to counter that imbalance and make sure we add enough valid parentheses to make sure that we have groupings of only valid parentheses or only valid groupings. So now we'll actually iterate through the input string S. So we'll say for I in the input string S, first we have to check if I is actually equal to a closing bracket. Or a closing parenthesis rather. So if I is equal to a closing parenthesis, then we have to check if the stack is non-valid and the most recent element that we've added to the stack in the previous traversal of the array, or basically stack at -1, if that's equal to an opening parenthesis, then we know that this is going to form a valid grouping of parentheses because we know we have an opening parenthesis right before a closing parenthesis in this iteration or traversal of our input string S, and so we can stack.pop, basically just removing any valid parentheses that make up or form any valid grouping, because we don't have to worry about them to make any extra moves to make them valid because they're already valid. Otherwise, if it's actually a closing parenthesis and this does not evaluate to be true, then we know that this is going to be one more closing parenthesis that does not form or is not part of a valid grouping, and so we'd actually have to add that to our stack as one more invalid or imbalanced parenthesis, right? And of course, if the current element I in this iteration is not even a closing bracket, we know we can immediately add that to our stack as one more closing or opening parenthesis that still has to be closed. So it's still imbalanced or invalid until it finds a companion closing parenthesis right after it to actually form a valid grouping. And ultimately, outside of this for loop, we just have to return the length of the stack, which tells us the number of elements or the number of parentheses that aren't formed or that don't make up an actual valid grouping, and so we'd actually have to return the length of the stack, so basically counteract that imbalance by making that number of moves to counteract and basically provide valid parentheses for each imbalanced or invalid parenthesis that does not form a valid grouping. And so unless I made any syntax errors here, this should be accepted and it should be submitted. And as you can see, this is just about as efficient as you can get. So again, the reason why we do if stack and stack at -1 is equal to a closing parenthesis, or rather opening parenthesis, is because we can't just have if stack at -1 is equal to this. And the reason why is because this would actually give us a list index out of range, because what if our stack is empty? We won't have a stack at -1, and it's going to throw us an error where our indexing for this current iteration of our stack is out of bounds. So we actually have to check if stack is non-empty And so then we can basically be guaranteed that stack actually has a most recent element that is a potential close or opening parenthesis. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. So for the runtime complexity of this program, this is going to be big O of n because of course this is a one-pass solution where we traverse through the input string s once. And also this is going to be big O of n for memory as well because worst case, we're going to store every single element in our stack because none of them are actually valid or none of them are actually forming valid groupings. So if you guys enjoyed this solution, please subscribe to my channel and smash that like button. And without further ado, I will see you guys in the next video. Bye-bye.